Hello, my name is Warren Charter. I'm a design principal, one of the founding partners here at Charter Sills. And today we're going to present on how to do lighting calcs. So the lighting calcs that we're going to talk about today, this is not how to go back to your computer and set up a really detailed AGI 32 calc for an entire space. This is more the down and dirty. I have a fixture that I really like for the project. I want to run a calc to see how this fixture is going to perform. And this is taking it beyond what, maybe the spec sheet is telling you, or, if you're working with a rep, it's a good way to just kind of, work with them to see what this fixture is capable of doing. So if you are an architect or maybe an interior designer, and you want to keep that meeting going and you want to keep the process going, these are really easy calcs that you can, I call them the down and dirty calcs that you can keep in your back pocket to just kind of verify and validate a fixture idea or a solution to see if it's worth pursuing, or if you should look at alternative ways of illuminating a space. So the three calcs that we're going to look at today, the first one is the inverse square law. Throw an R in there. And I will be abbreviating whenever possible. Okay, the inverse square law. The second one is the cosine law of luminance. And these two are tied together very nicely. We typically, as architects, are not good spellers. The third is the Lumen method. And the Lumen method is that's a nice, easy way to kind of get a handle on how many fixtures you might need for a space. So it's the top two, it's calcing out kind of lux and foot candle values. And the last one is telling us how many fixtures. So inverse square law, cosine law of luminance, and the Lumen method. Now, let's go over a couple terms real quick before we get started. And I'm going to write some conversions up here that we're going to use as we move through this. So let's start with the three that always come up, all right? So this is, typically there's questions on this. Lux, lumens, and the last one is, why is it slipping my brain here? Candela. Okay. So I'm going to put these in more just easy terms to try to tie these all together. So lux, or sometimes, the way we're kind of driven, it's more foot candles. Lux is the amount of light hitting a surface. So light on surface. When we talk about a lighting installation, we're working with clients as a designer or an architect, interior designer. The question always comes up, what's the foot candle value on this table? If I'm doing fine dining, is that table receiving 5 foot candles, or is it receiving 50 foot candles? So lux will refer to light on surface. Lumens, that's just raw lighting. That's all that represents. That doesn't really give us an idea of what that fixture or that fixture lamp combination is capable of doing. I'm going to make a number up here. Let's say I have a 1,000 lumen A lamp, you know, just a typical light bulb, and it's just throwing light everywhere. So that 1,000 lumens is throwing light across the whole room. If I take another type of lamp, let's say it's a spotlight, and I have, with that spotlight, I've got my beam, got the field around it, and it's also 1,000 lumen lamp. So chances are good, most of that light is in this initial beam that's coming down, not out in this area here. So the lumens, although we look at a fixture and we say, what are the lumens? What's the lumen package like? If we have an understanding of that category of lamps, say a spotlight or an A-lamp, knowing the lumens can give us a rough idea of what the performance is going to be like. But in terms of, you know, layman's terms, it's just raw lighting, okay? It doesn't really, the lumens doesn't say, hey, it's going to be enough light for that piece of art necessarily. And then candela, that's where we start to get an idea of where is that light being distributed? How's that fixture lamp combo utilizing that light? So candela, I like to think of it as its intensity and direction. Those two together. Most of the candelas on this lamp here are directed down to form this tight beam of light. The candelas and intensity on the A lamp is it's more soft and gushy, and it's everywhere. So it's just, you know, throwing light in all directions. So candela is the reference to, and if you go to a manufacturer's cut sheets or spec sheets, you'll see their chart for candela, and it's going to tell you based on various angles what percentage of light is going in that direction and the intensity, the intensity of that light. And that's what you can use to kind of determine if it's a right fit for your application. Okay, so those are the three terms. So we got lux or foot candles. That's what we read, the light that's actually coming down and hitting a surface. Lumens, it's just raw lighting. It's just the engine. And candela is intensity and direction. It's where we send in that light. Okay. So now let's start with, I'm going to throw up here a couple conversions we're going to use that as we move through this. So the first one is 1 lux is equal to 0.0929. And because these are down and dirty calcs, I'm not using these for final lighting calcs to validate a design. I mean, that's where this, if we like the direction, the idea, these mini calcs, those solutions would, then we'd be putting those into like an AGI to run the calcs. But for this, it's not rocket science, right? We want to get an idea of performance, and we want to get an idea of maybe how many fixtures. So on this, because we're so close to 10%, to make it easy on ourselves, we're going to round this up to 0.10, or we could say 10 lux equals 1 foot candle. All right? We tend to gravitate towards foot candle more than lux. We use feet and inches over meters. But a lot of these calcs are set up to run lux and utilizing meters, but there's an easy way to kind of convert that over. So that's one of our conversions. The other one is on the measurement side. So 1 meter is equal to 3.37 feet. All right. Okay, with that laid out, so the first one we're going to present is the inverse square law. And so with the inverse square law, we're going to run the calcs, but basically what it's saying is, so if I take, let's say, in the olden days, we're talking about a foot candle and it's throwing light. And if I go out, say 1 foot, and I get a measurement of light right here, which is 1 foot candle. Well, let's, every time we double that distance, so now if I go out 2 feet, the amount of light that I have here, if it was 1, is reduced down to 25%. So now I have 25% of what I had at 1 foot away. If I double it again and I go out to 4 feet, again, this measurement of 0.25 is cut down to 25% of that, or 0.0625. Usually we're dealing with bigger numbers, but so it's going to, that's what we're working with the inverse square law. So the formula for that is I equals K over D2, where K is going to be our lux and D is going to be our distance. So if I have a fixture, and I got to work in my lamp images here. All right, so if I have a light source up here and I have a surface down here, directly under the bulb, straight down, what's my lux number for the surface below? And I'm going to take into account the lux value of the lamp and the distance between the source and the surface. So for this exercise, we're going to use 1200 as our lux. So K is lux, and it's 1200. D is distance. So I like to say source to surface. And for this, 3 meters. Okay. So we plug that in. So I equals 1200 over 3 squared. So we got, we'll show all the work, 1200 over 9, and then 1200 divided by 9. I did this before, so I know it's going to be 133 lux. So I can use my conversion up here if I want to know foot candles. So since 10 lux is 1 foot candle, we can just take that back to 13.3. And again, that's an approximation. If I were to actually multiply by 0.1, this would probably come out closer to 12 something. All right. So that's the calc we use to just do. And again, it's just a nice, easy calc. You're working with a fixture. You want to know, it's like, I know I need to mount these at 5 feet off the, above the work plane or the table or whatever you're lighting. And I want to know, is this fixture going to get me in the ballpark? So maybe at this, distance here, 13 foot candles is too much, or maybe it's too little. So what kind of changes can be made to either location or fixture wattage just to keep pursuing this as a viable fixture in the solution? All right, so let's see, we're going to keep some of this stuff. Now, move on to the next one, which is the cosine. law of luminance. For this formula, this comes into play when maybe we're throwing light back at a wall, or maybe we just want to get an idea of what the lighting is, not directly underneath, but over to the side at an angle, right? So what we want to know now, our distance that we're looking for. We're going to say, well, what's the lighting doing over here? Okay. So for that, the formula for this, it's simply, we're going to multiply it by the cosine of the angle. So this is our angle right here. So this is what we're interested in. That's what we need to figure out the cosine of the angle, and then we can determine what the distance is and do the calc. We already know, so for this basically, we need to solve for this distance right here. And we're going to use the Pythagorean theorem. Most of us have used this quite a bit for various things. Oh, let me get this written in over here. Cosine so the light angle. So we know what the distance, or we want to find the distance. We know what the drop is here from previous. So we're going to call that, we're going to change that to A. We know that this is 3 meters. We're going to set this up so the distance out on the horizontal plane, so going straight down to the surface we're lighting, going straight out to the point we want to calc to, 4 meters. We're going to call that, this is A, gosh, that's a terrible A, and this is B. And so with the Pythagorean theorem, it's set up C squared equals A squared plus B squared. For this example, D is our C, so it's D squared equals A squared plus B squared. D squared equals A is 3, so say 3 squared, we know that's 9, plus 4B squared, which we know is 16. So D is the square root of these two, which is 25, which gives us 5. So D is 5 meters. So now we have everything we need to do this calc. Super easy, right? Back pocket, easy stuff. To figure out the cosine, we're simply going to take these two measurements over each other. So we're going to take A. So for our cosine, okay, I'll write over here. Cosine is A over D. So it's the two, the angle. So we know A is 3, D is 5. 3 divided by 5 gives us 0.6. So now we have everything we need to do the calc. So we have 1200 over, it's still, now the distance is 5, so it's 1200 over 5 squared times our cosine, which is 0.6. So we have 1200 over 25. Oh, let's see, we have to do this one. So 1200 divided by 25, the 5 squared, times 0.6 gives us 28.8 lux. Or we could say 2.8, and we'll just call it 3 foot candles. So the difference between directly under the fixture where we had 13 foot candles, and then when we're 5 feet out on an angle is 3 foot candles. Okay, so we know from our previous calc that this was 13, this is 3. Where this also comes in handy is if you're looking at, you can add in another layer of lighting, and you already know what the calcs are going to be in reverse, so that if you're starting to build a grid of fixtures, what kind of light levels are you getting from multiple sources? So in this example, if I were to take, let me get rid of some of this stuff. Switch to a different color just for fun. So if I were to put in another of the same type of fixture, that's way too light. If I were to put in another fixture directly above my outside angle here, the same fixture type, we know that that light coming down here is 5 foot candles. And we know that the light carried out to here is 3 foot candles. Did I say 5? I meant 13. All right. So if we do the math on this, man, I'm having a hard time here with the math. 16 foot candles. So we know that the total amount of light hitting these two areas is 16, and it's going to be dropping off somewhere. It's going to reduce down on this area here. So it's just another good way to, do you need to pull the fixtures apart more? Do they need to be closer together? It's a great way on the fly to make some decisions on pursuing a lighting idea. And I'll say it again, with all the apps and the computer programs, we would not do these calcs for an entire project. We're not gonna sit there and do point by point calcs for everything. But in the early stages, sometimes it's quicker and more beneficial to set up these calcs. You spend 10, 15 minutes versus setting up a whole, AGI program just to get an idea of what's happening. It also, I think, when I remember going through architecture school, we would have a field trip to a new project. We're going out to a field, we've got a stream, we've got a bridge that goes across it, we're going to build a retirement village. And everybody wants to take pictures of the site. And I remember our professor saying, no picture taking, sketch everything that you see here and take it back with you, sketch it, draw it. Because that sketching really helps us to understand and pull in what we're actually working with, where a picture is just a picture. You're really going to understand it with the sketch. And I think sometimes when we're doing these types of exercises where we're actually sketching out where the fixture goes, where the lighting is going to go, it helps us get a better 3D image of what's happening within that space. Whereas when we look at a printout of calcs, yeah, it's a bunch of numbers, and we understand what the numbers mean, but I don't know that it has the same impact for everybody. So I just find this helpful. All right, so the last one, we can get rid of all this. And there is, I don't know if we'll have time. I don't think we're going to have time today, but it's really easy on these calcs to run the same calcs with, instead of lux and meters, to run it with for foot candles and feet. So all of these can be done either way. All right, so the Lumen method, this is just a down and dirty way to figure out, I keep saying it, down and dirty. So how many fixtures do I need for the space? Do I need 4? Do I need 20? Sometimes the question comes up, we're working on a project, you know, the architect, the interior designer, the question comes up, hey, we really like the fixture, how many do we need? So this is a great way just to figure out, in a very rough sense, fixtures that are needed. So the formula for this is N equals, let's see, what is the first one? It is, lux. So let's see, and they're using, for lux, they're using E. Okay, so it's lux, so E is lux, times A, area, over lumens times coefficient of utilization times light loss factor. So again, this is, we're using this just to get a rough idea. I'm never going to use this to do a final calc. And when we run this in a design software, it's going to do a really good job of, you know, applying the coefficient of utilization and the light loss factor for that fixture lamp combo. And coefficient of utilization basically is, that's where we're taking into account reflectances of a room, and we're taking into account the size of the room. So it's going to factor in, you know, some examples are for reflectances. You'll see this on the manufacturer's sheet. If it's, let's say it's a 70, 50, 20. 70% reflectance on the ceiling, 50% reflectance on the walls, 20% reflectance on the floors. And it's going to be a percentage of what we're going to, you know, how much of that is going to go forward of everything that we put in. The other aspect is for the space. Is the space really tall and kind of narrow? Is it a normal space? Is it normal in width, but it's really long in length? So those factors will go in, and those two items combined. So the reflectance and the space, I don't know, I want to say the space volume. Those two things will make up this number, and it's typically going to be, you know, some number that's, you know, I'm throwing this out there, it's like a reduction, a percentage. So for this exercise, we'll use, we're going to say it's 0.91, just for fun. Light loss factor, that's taking into account everything from like your lamp lumen depreciation, your lamp dirt depreciation, the dirt in your environment, ballast factor, the driver factor for an LED. Are you installing these in Arizona where it's going to be 105 degrees, you know, midday, and it's an exterior fixture? Everything that would go into reducing and impacting the performance of that lamp. And it's also the history of that fixture. So we're designing all this. So all those factors, let's see, for this one, we'll use 0.89. So we're designing this for we're always designing for maintain light levels, not initial, not what's going to come out of the gates and be super cool and super bright, but what's the space going to be like when I come back in 5 years, when I come back in 10 years, when I'm going through normal lamp changes and stuff. We take into account, what kind of dirt and those factors that are ultimately trying to just reduce that light output. All right, for this exercise, our lux is going to be 500. Our area is going to be 6 by 8. Our lumens will be 4,900. And for the calc, lumens is always going to be the total lumens for that fixture. So if you're still doing some calcs for fluorescent for some reason, and it's a 2-lamp fixture, it's going to be the total lumens for both lamps of that fixture that go into this calc. All right. So lumens, just our raw lighting. So we set up the calc. So we got 500 times 6 times 8, our area, 6 by 8, meters. This is all in meters, by the way. Okay. We're doing lux, and this is meters. Divide that by 4,900 times 0.91 times 0.89. So this math is easy. 500 times 6 is 3,000. 3,000 times 8 is 24,000. So it's 24,000 over, and I'm going to use a calculator for that one. So with our light loss factor and our coefficient of utilization, it's going to take our foot candles down to 3968. All right. So now we simply divide 24,000 by 3968. Oops. And we get 6.04 fixtures, or we would just say 6 fixtures. If I had done this, and let's say these numbers were not as good, let's say this was 0.85, this was 0.75, and so this is reduced down to, and I'm just making up numbers. I'm not, all right, so let's say this is 49, came down to 3,600. So we take 24,000 divided by 3,600. It says I need 6.6 fixtures. So now I'm estimating that I'm going to need 7, but typically if I'm doing a layout for a room, maybe I'm going to say, hey, for this project, we might need 8 to kind of create that base layer of lighting. Now going along with this, hopefully, this is just your workhorse light source for the space. Maybe, outside of it being a warehouse, if it's a decent interior space, then you start working on accents for the wall, pendant lighting, coves, all the other lighting that goes into the space that might start to even change this to where you don't need to have 8 fixtures, but maybe 4 fixtures is going to be enough, because you want enough contrast and you want enough going on. So again, this is very helpful if you need to know, will this fixture work in this space? And if so, how many of these fixtures do I need? And let's see, with that, I want to thank everybody for staying with this video and watching it through. Hope you pulled something out of this that you can pull out of your pocket during a meeting, and you can be the coolest person in the room because you're helping to keep that discussion going forward. Nobody's walking away with, well, hey, we'll go do the calc and we'll come back and get back to you, but you can figure it out right there on the spot, get an idea of what you want to do. Again, it was the inverse square law, the cosine law of luminance, which are tied together, and the Lumen method. The end.